Okay,
MGM.
GM, sunny day. We're going to talk about a lot of good stuff. All right, welcome to Modular Restaking. How do you compound your restaked earnings, right? But who can do it, how to do it, and how difficult that is. Do you want to bring a new ETH, or you want to add a new validator, or is it possible for solo stakers? Is it only for staking pools, or or is it available for anyone? What can you do with this?
And,
So
and what is the, helping the break even point, right? It's
yeah,
always a big question now
yeah,
especially for solo stakers. The
right,
consensus layer is consistently paying less and less.
absolutely. So and we are going to see more and more staking. So this is part two. Part one was there as a PWC. So there's a small change from it gone from programmable to modular. So that's a recap. We discuss about how it goes in line with all the restaking protocol. How can you give multiple approvals to multiple restaking protocols? That was the part one, right? Essentially saying that you have eigenlayer, restaking cloud, and many will come as for the restaking offerings. And how can you give approval based restaking, so you can revoke the approvals and then you can manage how much each validator can give. That's one thing. So that's still you are like giving to a protocol and certain things, but we want to expand this capability back to the validator, and we are going to introduce modules. What that means is like a single validator could have multiple approvals at the same time, but in aggregate, you always have this kind of a risk profile on chain, and every other modules that has got the approval from the validator underlying stake as a modular withdrawal credential, they can actually know is there security or the drawn credit line is good or not. So in the module, we are taking we are taking an approach to understand the monetary part, the DeFi or the financial aspect, the asset aspect of underlying staked ETH. So we discussed about how you extend the shared security for others, but this is more of like how do you extend the shared liquidities? How do you reuse the underlying staked ETH? It's about we have about 31 million ETH sitting at consensus layer. How can we make it available for execution layer and rollups and other people to use it, so we can get this all the abstraction tooling, like talk about account extraction, talk about pre-confirmation markets, talk about shared deposit, talk about shared sequencers, MEVs, or you talk about like the DAs, the blob market, sovereign stable coins and everything. Yeah,
They're just new markets, right? I mean, it's something that's been in discussion since DevConnect Amsterdam, right? You did a talk in Economics about this,
right.
shared security, not security,
Because
economic bandwidth.
yeah, the bridges, the rollups, everything fragment the liquidity from L1 to all the L2s, but then everyone is fighting each other for getting a liquidity. It's not going to be possible. We've been calling this like 3 years before. This is going to be the problem. The fungible, the shared liquidity will not be there because we already giving a shared security. So now the biggest change in the rollups is like you can have one server doing the execution and just throw the DA or throw the proofs from in a periodical manner. That's called the rollups. Now you can have thousands or 10,000s of it. Now we have seen varieties of those rollups, like the blast, which just had a hack or something like that. How do you do the recovery? So all these execution environments are not necessarily having the same security measures like in L1 on execution part, because it's a different EVMs implementations, different sequencer implementations. There are a lot of things that is not there. So the assets goes there have a different, not only fragmented
Security
liquidity,
assumption.
not only fragmented liquidity, it has fragmented security assumptions. So the
Mm-hmm.
security part, the restaking part, like the K2 and other kind of services, could provide the security in a aggregate security for everywhere that you're taking it as you go in a fungible manner. But now we have an asset sitting there. How can we reuse this asset and onboard a billion users, right? That's the most important part. How can you go beyond the DeFi, go beyond just lending and borrowing, not just
And
the
the
money
asset,
market.
just to be clear, the asset you're talking about, it's ETH, right? We're talking about how can the asset be used in many markets, but from the base L1.
Yeah. So underlying assets, so your monetary base MB, let's call, and that's ETH, staked ETH. And anything that any markets that you're creating, any kind of things that you're lending it for, it's really ETH based, right? So we're creating a new kind of financial ecosystem, ETH based. But now ETH is available from the stakers can give that ETH and they will earn an additional yield. So put it simple, if you're part of Modular Withdrawal Credential, you're giving approvals, the stakers are giving approvals in return for additional earnings, period. Right? And the modules can actually use it, but these are predefined conditions, only smart contracts can use it. So there is no surprises here. So they know the risk, but in return, the modules also know that how much ETH is at stake and how much ETH they have backing. So there will be no, solvency problem. So maybe we talk about a little bit about the solvency based. What is a solvency rule in formal verification? How does this basically how the smart contracts are verified, like a CDP or wrapped ETH or something like that? Why it does have a value when it is backed by an asset, right?
So the staked ETH can be approved for remarketing by some kind of other protocol. So the staked ETH manager can be sort of passive in this scenario, whilst the staked ETH is being remarketed to these other marketplaces that you're talking about,
Right.
and earn some additional revenue from that. That is the key thing here, right?
Yeah. So everyone can use it. So all the LSD staking protocol, solo stakers, LRTs, regardless what the tokens that you have in the deposit receipt tokens there, this is based on staked ETHs. So you're giving approvals based on your staked ETH balance on consensus layer, and you can do it on execution layer withdrawal credential. So what are these markets? I think we have an MWC market descriptions, like how this basically work is at the higher level, everything is being given at a nominal interest. So if you're drawing, it's kind of a borrowing from the stakers. So who can subscribe to this market is up to the stakers. Any ETH staker, when I say ETH stakers, they come in different shapes and different forms. Some of them are just a staking pool, so they may have like 10%, 20%. Some of them are solo stakers. Some of them are institutions. Some of them are like stakehouse kind of ecosystem where they have different pools. So it depends on who is the calling the shot. Like the staker, we have a one single entity ETH validator. If you're an ETH validator, if you own, then you make the call, and that's the withdrawal credentials. You can give an approval. You can take this decision at the DAO level, as an individual level, at the institution level, whatever. So you get some earnings from it, right? Every approval that you give, and it's predefined. So it's kind of a credit line extended from stakers to all kind of other innovations. And the credit lines are backed by staked asset, and the credit lines will put more ETH at stake under management, or you can even manage other assets. So for example, if you have an NFT portfolio, if you have something else, you can do that. But then the stakers can decide if they want to give a credit line for that. It depends on the volatility. Or you can, give a mortgage, real world assets or something like that. And then if you have some trusted party on the other end and they give you the money, that's great.
Yeah. So you have to, I mean, there are various attempts at extending credit lines on NFTs, and it's difficult because how do you attribute value to these assets? It's very easy to understand the value that comes from ETH and extend a credit line regardless of where the staked ETH comes from, right? So I mean, you need there somewhere like a benchmark rate, but to do that. That doesn't care about where the staked ETH comes from, but at a base level, when you're talking directly from the consensus layer, you understand the monetary base there, right? And you can give a fungible credit line out from this asset, maybe with some kind of buffer, maximum ceiling on that credit line. And the traditional banking system is doing this with with fairly ease. But what's better about this is that it's all the information is all publicly available and verifiable on a blockchain level. So whereas it's much harder to kind of audit. Yeah, this is an auditing point I'm trying to make here. Is it's so much easier to audit a credit line created from a staked ETH asset because there's always a chain of custody. There's always a way to follow the money, always.
Yeah. So the on-chain accounting, on-chain inventory is great. So you can always, get the solvency rule correct, right? There's no money printed out of thin air, and there's always something is backing it behind. And in this case is ETH all the time. And whenever it is being reused, it's a false multiplier, and it just make more and more revenue for the base, the ETH at stake, and then who are the modules or who are the markets that has been using, they make their own revenue as well, right?
Can you expand more on the force multiplier?
So the force multiplier, like if you are modular withdrawal credentials, what is a withdrawal credentials? We're going to get into that one. So if you have, let's say, if you have a 32 ETH and you're giving 24 ETH approvals for others, a protocol to use it, let's say I'm going to mint an asset from you. I need a 24 ETH, so I took 24 ETH approval from 1,000 validators. So I have 24,000 ETH worth of a token that has been minted in a faucet, pre-minted in a faucet, and I want to give this for liquidity purposes, right? I'm not going to give it for free. So I borrow it from at a nominal interest, let's say about 4 or 3%. I'll say I'll give it to you whenever I'll find a buyer to reuse this, right? So wrapped ETH, think about wrapped ETH. Wrapped ETH is the 60% of an Arbitrum and other kind of rollups using for the thing, because it's always 1:1. You can always bring it back, and then the ETH is there. So force multiplier is you're not giving a validator can actually give multiple approval with the MWC. You can actually give, I would say unlimited, but still there's a limit to rights and how many approvals that you can give. In the sense that what the markets would be able to take your credit line. So if I'm the market and say I'm looking at your withdrawal credit, the BLS key and associated withdrawal credentials from the MWC contract, I will know how many approvals you're given, what is the kind of approvals that are being given as a smart contract. As a smart contract, I can reconcile how many approvals are being given, what is the nature of this approval. Is it only for kind of a lending, like Aave kind of markets, or you given for some sort of a collateralization ratio where you take a hit, or you given some sort of a perps or things like that. So the smart contracts can reconcile immediately the risk of taking a credit from a credit in a bank. So this is like very analogous. If you want to step into a Wells Fargo, the balance sheet of Wells Fargo beforehand. If you're giving your savings depositors, like, I want to take a loan, but you're shitty bank, I don't want loan from you because your money is not good for you. I will be in trouble. So,
but it also works the other way around about the customer borrowing, right? Because obviously customer borrowing has a credit score and ability to repay. I like these real world examples. So let's talk about car finance for a second. So a car finance company, let's say there's a company, Santander, right? So they are able to borrow money from the Bank of England, maybe, and then maybe not 100% accurate, but then they will then remarket that liquidity to their customers based on the credit rating, right? And they may be able to borrow more to the customers, but it's for a specific purpose. This is where I wanted to go down, right? So they're not going to give you, like you said, they're not going to give you money for anything. It has to be for a specific reason, for a car loan, or for the purpose of buying a house, right? Governments are always underwriting the mortgage security, right? So here we're replacing a central bank with Ethereum staked ETH. Am I getting along those lines? Is this or are we getting too abstract here?
Metaphorically, yes.
Okay.
Yes, so we are creating a sovereign, trying to bring up a sovereign and a credit markets. Yes. So that's why we
Yeah.
call the monetary base is Ethereum stake. Yeah, at stake.
Yeah,
Yes.
but Ethereum is always solvent. And
Yes.
as long as the blockchain continues to operate, it has always got the ability to mint and print more ETH. Always.
Right. So, for example, in this case, let me swap that. The car loan, the bank that you use the auto loans, they know that how much rate they can give and different kinds of auto loans. So if you just think it like I'm gonna give this loan for an intent provider, okay, and the intent's like I'm gonna use it for trading, I'm use it for other kind of protocols. So they know what is being used for, but they have it right how much they will be using it. So if you agree in advance, like, oh, I will pay you 4%, you give me this predefined conditions, and I'm gonna give this for making routing trades and things like that, so my liquidity problem just went away and I can use it for anywhere. But that's a different conversation. Where can you use it? But this will immediately give you enough liquidity, ETH back liquidity, for protocols to draw a credit line, and then they can create all kind of instruments. Even you can provide an instrument for credits that will be immediately mint the tokens and paid, and then they recollect it from the user at a later point. That's what your car loan does. They give you something as a car, they possess the ownership, and then you repay it back. There's a depreciation cost, so they repay it back and then they give it back to them. So
Yeah,
they
the money
cannot just
never.
give you. Yeah.
Well, no, exactly. That's the yeah, exactly. This is where I was going to go. So they don't give you the money to buy the car in most circumstances. It will go directly to the dealership or whatever.
Approved dealership.
Approved. Right. And then
So
you get the keys, right? And you drive it
yeah.
as long as you pay the monthly payments.
Right. So there is always that's a predefined rule. How you're doing this. So yeah, so potential use cases are huge because we cannot bring fresh money to do all this innovation, but we just need to use endogenous money. And that's how the market works. That's how our economy works, where the money supply comes in and the liquidity will be reused and paid back for the original canonical source of that lenders. That's the monetary base. In this case, is the stakers. And then now you can immediately available. So the stakers, in a nutshell, the stakers are going to get a lot of yield just protecting the staking. So now you don't really have to go for very speculative opportunities. This is a very endogenous market that you can ETH at stake could have more yield from supporting all kind of scaling, rollup-centric, or stable coins or flash liquidities, all the smart contracts. So this makes an yield opportunities much more closer to an ETH staker world, regardless who you are. You could be a solo staker, you could be an LRT, you could be an LST, you could be anyone who has a validator. That's a single metric. Anyone who has a validator can access this market, and they can make the decision how many times they want to get exposed to the market and how much. There's a risk, but there's also opportunity there. So that's something that you can subscribe and you can unsubscribe. So it's not like you're giving all of it, but we'll go into it. Like, how does the threshold and slices and approvals, each approvals are different. This is amazing. We're gonna get into all kind of stuff.
I'm a big fan of ETH-backed stablecoins. ETH only
ETH
backed
only, ETH
stablecoins.
only.
We used to have single collateral DAI, which was known as the unstoppable dollar. So
You
let's see
could
if we can
have
bring that back.
You could have multi-collateral markets, but it just being, you can have this kind of, the base faucet could be from ETH. So you bring like, 1 billion stablecoin has been minted, and then you can have the asset under management could be multiple collateral, and the off ramps. If anyone want to burn that stablecoin, it comes back through ETH, because you will have like thousands of dealers all around the world. So that's the important part, is off ramp and on ramp and off ramp. When people are putting it, how the enablers can take your money, and how the enablers can actually give you the money the currency that you want. We'll get into that. So this is payment networks, stable coins, you name it, anything that you want to have it. So essentially the MWC, the modular withdrawal credentials, enable a compound restaking every single time that your yields are compounding. So the approvals that you can make it, it's up to you. What it brings is it brings every validator that is participating, or every ETH or staked ETH is being backed by this MWC, has an on-chain validator risk profile provided by the PON stack, proposed registry. And then you have a completely modular approval route. That means it doesn't really collapse. Like you're not giving one approval to all of it, but you can have different rules and different the risk parameters. You can have triggers, you can have hooks, you can unsubscribe it anytime, you can terminate it. Each and everything can have its own role, or you can bundle it up. No problem. You can give to someone else to do that for you. So that means a protocol. So the DeFi primitive will be based on this kind of newly, freshly injected liquidity directly by ETH stake.
And it takes away all of the all of the decisions around do I allocate to do I allocate here or do I allocate there, because normally it's an all in or nothing, right? So you cannot slice it up, which is you kind of saying, okay, well, I have to back one horse, and then if I want to withdraw, it's going to take like 2 weeks to withdraw and then rotate into a new credentials, right? So, this is a problem. This is not very fluid.
That's very true. That's a really big point. Like, okay, that's really the core issue, right? If you walk into a bank, you and me go into a bank and ask for a loan rate, there is no guarantee that I will get the loan, even though I have the same job and everything, and you're going to walk away with the loan in the same rate. But the blockchain is making that flipping, like it's permissionless. So regardless who you are, what is your branding? If you want your money, we'll give you the money. And the permission is based on whenever you use this, give me back the nominal. It's been taken care of. This opens up a whole new set of markets where you don't need permissions. You don't need prerequisites from non-existing, the parameters like, oh, we're big, we have this much followers and things like, no. Everything comes as smart contracts. What are you using it for? For example, in a hackathon, you want to use an earn vault on our market, borrow it, I will give it to you, right? So that's the beauty of a smart contracts. You can take it and you can repay back. So it's up to you. It's what do you want to use it, how innovative that you want to do it, but it will really accelerate all kind of use cases, bridging, multi-chain use cases, ZKs, all kind of passwords and things like that if you want to issue it, or I don't know. I mean, I can just think about like in many use cases right now. If the money is available, ETH liquidity is available, where I don't really have to beg to anyone. Just making it easier.
On demand, it's just a matter of what you're going to pay based on the risk profile, right?
Right. So the whole stack is credibly neutral. So that means there's no external parties, there's no Oracle, there's no other kind of things. It's just on-chain record. You can go, if they subscribe, and you can ask, you can put it up, they can see everything. Everything is on smart contracts, everything is on-chain, and you can do it in permissionless way. It's seizure resistant, censorship resistant, one of them, just L1 Ethereum based. That's it. If you have an access to Ethereum, you get all of this, period.
Right. Which, and that's, we'll get definitely into how that's achieved. But yeah, like you said, it's the neutral stack, which is proof of neutrality, fully transparent registries for proposers that allow proposers to be registered on the Ethereum chain. So you've got to understand that obviously here we're talking about two chains connected together, but with different cryptography, right? So you're representing your validator on the execution layer with a representative address, or you may have more than one, being represented by the same account, and then you have
So the reason that we're saying here is 0.01. There will be a 0.02 soon with the max effective balance compound staking. Stake compounding will come in the next upgrade. So the V1 version of the MWC, the modular withdrawal credential, is limited to the existing, smart contract based withdrawal credentials. So not 0.00. That's the BLS key that has been shifted. So anything that you're using 0.01 is that's the one that you can take approval. That's the one that they can give approval for, and all this kind of stuff, right? So that's one thing, but 0.2 will be enabled when that comes in. There's nothing stopping, but whenever that upgrade, it will come. So we're talking definitely from a 0.01. What that means is 32 is the max effective balance.
32. Which kind of like which drives the approvals, right? But for
yes.
But if you have effective balance much higher than that in future Ethereum upgrades, well then we're
gonna discuss this. Things. We're gonna dig deep into what is this 32? What is that single approval, or is it only thing that you can give an aggregate? We're gonna go into that, all of that in the next slides. So right here it is. You wanna give a little bit of color to this?
Yeah. So we have obviously detailed flow diagrams here, but this is a really high level one. And this is talking about how you're going to delegate the staked ETH representation from a validator. So a validator is represented by a BLS public key, BLS credentials. So it is on the BLS key where you have the staked ETH balance represented. That is where the balance is, and that has a credential which can prove ownership and attest and give permission for the staked ETH to be re-represented on the execution layer. And in between, if that stake, so what's important here is that the stake is active on the execution, on the consensus layer, because otherwise execution layer is not interested in it. And there's continuous monitoring, which we can talk about later. So once you have a delegation to the proposer registry, so you need to first represent your validator or multiple validators under a representative, and that is to the proposer registry. So you have a neutral proposer registry where you're creating a single sign-on for all of the validators that is being managed on the consensus layer. And on top of that platform, all kinds of interesting use cases are present, including the modular withdrawal credential. So you can just poke in once you have an on-chain single sign-on for the validators, you can poke the MWC application and inform it about a new registration to the execution layer. So that will expand your approval capacity. So the more validators that are present on the execution layer, the more approval capacity that you have. And you can see here that the approvals can be sliced up in many ways. You can give one protocol 2 ETH approval, one protocol 5 ETH, and so on and so forth. And you can also do self-approvals. Approvals can be revoked anytime. You can issue approvals to restaking protocols, and you can also issue approvals for extending liquidity to bridges, as we spoke about beforehand. But there's all kind of modules that you can build up on top of this. But this is all done from the security of the node. So this is pretty clear. This is pretty important. So you do not need to expose the proposer keys outside of the node. From the comfort of the node, the security of the node, all the delegations and approvals can be securely managed. There is also an additional SDK that is open source. Everything's open source MIT. So we can actually it can be audited and verified what is taking place. But this is a very seamless process that connects directly with the consensus layer. We're creating a direct connection from consensus layer to execution layer in order to make this possible. We've been doing research and development on the consensus layer for more than 4 years. So we know how to do this with our oracles. That is pretty key here. So there is no third-party additional dependency here in this system. It's you, your validators, and your withdrawal credentials, nothing else. So that's pretty key.
So one thing to add here, you may see in the diagram that is a restaking protocol and the modules. Because the restaking protocols, the reason the restaking protocols there, restaking protocols are its own market for restaking opportunities. Modules are like more in a sovereign markets where you're giving direct approvals, right? So that's like external markets. That makes restaking as a component accessible at an application level, at a smart contract level, for anyone to ask, staked ETH for their own benefits without bypassing the restaking protocol. So, for example, if you have, so let's say Lido, Rocket Pool, Eigenlayer, and all these things have their own withdrawal credentials. Like every LSD staking pool, they have withdrawal credentials. Stakeouts have their own withdrawal credentials. Like, it's all different withdrawal credentials. Like, so if you're given Eigenlayer withdrawal credential as a natively restaked, right, you can still use MWC approval because it's just a withdrawal credentials. It can check Eigenlayer. Oh, so the Eigenlayer quote unquote works this way. You give their withdrawal credentials approval, and then at a given point of time, you can always see that do they have a claim against your ETH that may comes out from your validator sweep and withdrawal balance. So we don't really have to go how they take it, but you can call that contract and understand, is there any amount subjected to deduct from particular validator, right? Eigenport. So it's just a withdrawal credential for MWC. And if you use a module, if you are an Eigenlayer restaked validator, no problem. If you're a withdrawal credentials associated with Lido, no problem. If you're just a vanilla withdrawal credential as a solo staker, great, no problem. If you are part of CB ETH and Coinbase things, no problem. Just as long as your validators are managed by consensus layer and your withdrawal credentials has been registered with the proposed registry, we have that on-chain profile. And we can always know that how much ETH is there at the given point of time at the validator, and how much ETH that is claimed against you, not only from the MWC market, from other markets too, whatever that is gone from the withdrawal. So Eigenlayer restake validators, natively restake validators, no problem. Make more stake through them, use this too, and you can actually use other protocols directly borrow from your thing. So you will actually earn more and more ETH-based returns or any other native coins and things like that. Your market's access is getting expanded. If you're restaking protocol, Node Cloud members, K2 protocol, you have the same opportunity. So it's accessible for everyone, every protocol, regardless. Even you are part of an existing restaking protocol, the modules still can take approval from you. Was that clear? Because how this is made it possible, we're gonna dive deep into it because it's very real time. It's auto reconciliation. It just checks everything. There's no delay here. There's no veto committee or something like that. What I'm saying here, there's no exogenous party.
It's purely neutral.
Yeah, exactly. I mean, you can have a veto committee if you have a module say something that demands it. For example, if you're an RWA, like in a real world asset, you want to have a trusted party to say that it's been done. That's okay. You can give approval. There's nothing wrong in it. So what I'm saying is like the underlying stack is credibly neutral, which demands it cannot have any exogenous party. It should just work, right?
Correct.
Okay, cool. Right. So this is the high level. Do you wanna give a little bit color or?
Yeah. So, firstly, it's we're dealing with from a validator. Validator needs to.
This is a flow, right? This is a flow. This is a flow. How you're coming into the MWC, and then once you step into the MWC, in between, what are the other things? So there's two different, part of that slide.
Yeah, that's definitely a good way to put it. You firstly, in that flow, we're talking about a registration in the validator registry. In order to do MWC approval, these are like the prerequisite. So in order to do MWC approval, you need to be in the the validator registry, and that has a minimum balance of 32 ETH. So then
That's entry rule. So
that's
you need to have 32 effective balance in order to enter into this market, right?
which is no different to the consensus layer.
Yeah,
In order
it's like
to
kind of
you
induction balance. It's an induction
Right.
balance for this. Okay, cool.
Yeah, exactly. I mean, you can register a validator credentials with 16 ETH or 1 ETH, you know, but the validator is only going to it's going to be considered for activation from 32 ETH. So that is the, like you said, the induction balance.
Okay.
But then, so a module will, so this could be a smart contract module that will subscribe and receive the MWC approval. So MWC will inform, it will inform the recipient that an approval has been received, and that can that allows the module to understand the risk profile, right? So do you want to accept an approval from a guy that's, you know, doesn't, you know, repay his debts, right? So that's something you can reject or accept. And then you have so this part is really interesting. So when the validator is, so validator will be earning ETH from earning inflation rewards from consensus layer activity. So consensus layer is one application, and there are activities that need to be performed in that application in order to earn additional ETH at the that comes from inflation. Additionally, when the validator exits, there will be some unstaked ETH there, right? So when there is so a validator obviously doesn't need to exit in order to repay any kind of debts. If there is a for example, you know, you can extend a credit line that that is minting a ETH-based stablecoin with some kind of collateralization ratio. So if the collateralization is coming a bit, you know, close to liquidation, the ETH top up can be made and can be automated to keep that collateralization from getting below the, you know, getting to a point where the liquidation will be triggered. There might be other ways that the lien will be created, but simply if you have an approval, if protocol has an approval from an MWC, then it can exercise a lien on any ETH that is in there based on the approval size. And that creates definitely new instruments, new interesting use cases. So that's withdrawal and lien payments, right? So there is a reconciliation at any time. You can reconcile a portfolio or a single validator status on chain inside of a smart contract, and know where the position is. Is the position risky? Is it bad? Is it healthy? Unhealthy? All these kind of things can be determined if a lien needs to be made, etc. And if there is a protocol abusing the lien, right, the user can revoke their approval.
Right.
So yeah.
So what you're saying is a very modular approval kits here. The core is happening at this level. Like, you know, once you subscribe to a module, a single or a multiple module that you can see, lending, flash liquidity, everything has different use cases, but you know what you're approving for. You can revoke that approval, you can unsubscribe it, and that will stop the approvals immediately. Or you know, they could also say that I don't want your approval anymore. They can revoke. So it's two-way street. But yeah, at any given point of time, as a freeze point that you look at it, you know that there's certain approvals has been made, how much you earned, how much that's something that if you've taken a loan out of it or something like that, you have to pay for them, how much that is there too. But that can go, the payment, the lien payment could actually go from even from the accruals itself before even touching the sweep or the withdrawals. So it's like the second order of the debt. So the debt's actually being paid if you've taken a debt. So if you're a validator staker, you can actually have an overdraft facility. I want to talk about this later. But then like you just say that self-approval, I'm just taking loan out of myself and I'm just using it, right? But you also give an approval for other parties to use your underlying stake and they're paying you the interest. So it's kind of self-paying interest. All the other parties are paying for your loans. And then you're trying to catch up with the people who are borrowed from your staked asset and you borrow yourself on the other side. So, but the cool thing here is whenever the sweep and withdraw, it checks both the sides, how much you have from the open market. And if that is not enough to pay for your obligation, then it will take it from the sweep and withdraw. But normally most of this can be canceled out. So it's really like multiple modular approvals, multiple modular yield racking, and you basically, using this for, I don't know, maybe you will get a 20% or something like that if you just do it. Or there could be protocols like yield protocols like that can just simply use it for modules and to lend your ETH, stake balance for other, different markets. And it just gives you, it takes a cut of a 10%, whatever that yield that you on it, but it automatically reconciles the debt. But it's being given by the MWC itself. That's the most important part, is the real-time reconciliation of debts and the payments, accruals, and everything is built into this. The modules don't really have to do any of that thing. It's there. And also the validator balance. So the modules will never end up with the validator stake doesn't have underlying stake, right? Because slashing is there. You're missing that. That's why the P1 validator is, that's why the on-chain registration is a on-chain risk profile. At any given point of time, no assets or no credit lines from this will never ever have there's no stake situation comes in. That's the replication guarantee.
Which is really important.
Right. So there's something that we said earlier, but it's really getting to the meat of it. Like, what is this modules? As you said, we have created this kind of tooling set that allow you the modules on the smart contract level. We also have modules of the node operators for the CLI tooling. So we provide this tooling in a full-fledged toolings for all the sites to participate. And really, this is the other part of the modules, right? What we're talking about. Don't confuse this with the MWC modules, but this is the other part of the module.
Yeah, obviously, like, the validator, the validator being represented on chain is being run by some node in some system somewhere. So any problems on the node will reflect on the validator, but there's no like kind of direct connection. The consensus layer only focuses on what the validator is supposed to be doing and whether it does it or not. So node operators have very secure, sophisticated setups. There's various elements that are air gapped for tight security. So there is a set of tooling for node operators called MEV Plus. So MEV Plus is a on the subject of modular again. This is a modular proxy software to the consensus layer. With incredible extensibility for not only consensus layer applications, so you can interact with off-chain systems, but you can also have validators drive on-chain systems as well. So the validators are directly connected for the first time with the Ethereum execution layer, and transactions are being executed on the execution layer on behalf of those validators. Now, there are existing modules for this MEV Plus. So MEV Plus has a simple core that understands how to communicate with the consensus layer. But community members, users, anyone can write additional modules, and you can have the base MEV Plus, and you can just with that simple installation, you can install additional modules from anywhere on GitHub. So the idea here is that MEV Plus never touches directly any validator keys. So we have that isolated fault tolerance there. So nothing is being exposed, but the validators, we can create secure on-chain representations of the risk profiles for the validators. So with additional modules, modules can be built for managing the approvals that we were talking about, the on-chain approvals, once the proposals are registered in the proposer registry, and that can be used for creating additional protocols can be created on top of that. Users can install modules that will allow, extending credit lines to rollups, etc. But there is a suite of there's additional software where reporters can actively monitor all of the validators being registered in the proposer registry and make sure that they're still active. So there are reporting modules where anybody can. You don't have to have a proposer to do this, but the proposers registered in the proposer registry can be monitored for their active consensus layer status, whether they're still part of the consensus layer, where there is still ETH representation, and proposers that have exited can be reported and kicked, and there can be there is normally compensation for the reporters that are doing that. So it's really, really interesting dynamic system that that is completely Oracle free.
Right. So essentially, this is a CLI tooling around the node operators, existing OPSEC setup, so they can engage with any kind of markets that leverage MEU Plus for the coordination or orchestration, right? So they don't, it removes the need for the key orchestration, like take it here, the SDKs, because you don't really have a smart contract capability there. But for the MWC market, if you're giving approval for MWC for each modules, you could give it from them. You can even modules can add their own modules to MEF Plus if there's something that we discussed earlier. If it is related to you want the validators to be involved in any way that for you do reporting or oracles and things like that, you can hire them and you can use that for yourself or sequencer or signing data, things like that. The package managers kind of DApp node, they comes with like hundreds of packages, and they can be really useful. 30,000 node runners that is decentralized and geographically decentralized. So this is another connecting point of how do we make this more modular world accessible for consensus layer OPSEC environment. So it's a CLI tooling. Nothing more than that, but it will open up all kinds of possibilities. How do these hybrid models work? Right. So let's get into the approvals. Boom.
Yes.
Okay.
Yeah. So it's a lifecycle based system. So you have finite states for each lifecycle, whether there is a registration of a validator. No registration will be 0, and then you have 1 is like a registration, and then approvals or the exit of a validator. So this allows at a glance understanding what has happened to the validator without relying on having to go and cross-check with the consensus layer. It's all delivered on a smart contract under a lifecycle status. You can, filter out and only deal with registered validators in an instance. It just allows cutting through all the validators that are not eligible for interacting with your protocol, for example. So as the inputs into the modular withdrawal credentials, you have the VLS validation of on the consensus layer, and you have information on whether sweeps were received for a validator, i.e. whether debts need to be repaid or whether the validator has exited. Anyone can report that. We call that like a balance reporting. There's a lightweight software, ZK lightweight software that gadget that anyone can run on any device, mobile phone. It's really, really, really simple software. It's not heavy and will work with any kind of CPU. So
it's ad hoc.
Right, yeah, completely, completely ad hoc. So, yeah, it's really optimal for such a thing. So, reporting the exit of a validator, yeah, that's an ad hoc scenario. So you need to do something on demand, very fast. Proof size is 260 bytes. Very small stuff. Yeah, very lightweight. So, from there you get who's the owner manager of the we call it a knot is it's the tying of it's the representation of a validator on the execution layer. So you're tying execution layer to consensus layer, and you're having this
State roots.
representation. Yeah,
Two
right.
state
Yeah, with
roots
the
has
state.
been tried. Yeah, tied.
Right. That's where we get this knot concept, right? And then from there you can read as well the approvals. So very, very simple. We have inputs and outputs, or inbound and outbound data flows that are very simple and easy to kind of compartmentalize and understand where things stand at a given point in time, at a given freeze point in time. So this can be broken down a bit further into more detail. So we have this concept of, on the consensus layer, you have this concept of max effective balance. And right now, according to the existing hard fork, there is a max effective balance of 32 ETH. Consensus layer doesn't care or want to know about any balance above 32 ETH. So all your stake weight, your voting, your rewards are all on that base effective balance, not the active balance of the validator. So when it has an opportunity, it will get rid of excess.
So to be clear, the max effective balance is a maximum stake weight a single validator could have in the system.
Yeah. No matter how much ETH you send to the BLSQ, via deposit contract. Yeah. It would so that's your max stake weight. Correct. Yeah.
So in this way that you're explaining, the max effective approval is a single approval from a single validator. What is the maximum effective approval we could give for a module? A single module, from a single validator, not necessarily all your other modules. Whenever you are taking an approval, a single approval is limited with this maximum effective approval.
And there's a buffer in there, right? Because because it's actually a very so although the neutral stack here and the MWC is able to track the status of validator, it is within some boundary and some buffer, because otherwise you have to sync a lot of data between L1 and between Ethereum execution layer and consensus layer, when it's going above and below the 32. So there is some buffer that's in there to basically say, yeah, validator can go offline, online. It's no different to consensus layer, right? So consensus layer continues to work even if one validator goes offline or a few validators go offline. It will still have global security. It is actually built and designed for failure, right? Failure is embraced. It's not like feared, and it is with a proof of stake system. Proof of stake systems can be rebooted from a given checkpoint, right? And this happens a lot, right?
Yeah. So that's the global reconciliation system, right? So you can actually roll back and then you can fork away from whatever the checkpoint that you want to say that the chain is good, the chain is not good, and you can actively take what is the chain health from how many leakages that you have, how many missed attestation that you have, and all this kind of stuff. So getting here the max effective approval, you have approval slices. So this is like further granularity on approvals. So at the beginning of the presentation, we have this kind of two staking protocols. You could give maximum approvals for each and every module. You can limit it, but at a global level, a validator that's MWC actually have this kind of max effective approval balance of per validator. Right now it's 32 or 24 to 32, but as a validator, you can set your own slices so that I want to participate in this. I want to test it out, but I don't want to give any approval more than 2 ETH. Okay, fine. That's your limit, local limit. And you can give that approval for restaking protocol. You can give that for 100 different modules, and that's all they can use it. So whenever they look up it's a lookup table, right? And when they look up your VLS key and your validator says that, it says that, yeah, 2 ETH has been approved. Does it have 2 ETH? Yes. Does it have an active validation status? Yes. That's what it is. So your
Yeah,
local approval, you can manage it.
Well, yeah, and people might be jumping and thinking, how does, well, how do you understand what kind of lien that might get enforced upon you? But I think it's like always, interesting to look at, what the consensus layer does. So even though you put 32 ETH at stake, it doesn't mean that if you have a penalty that you're going to lose the full 32. I mean, in a coordinated, correlated penalty, there's like that's a black swan scenario event, right? But that aside, the maximum amount of penalty that, for example, consensus layer can apply to you for being offline has an upper bound, and it's less and less more validators that join the consensus layer. So it is not an unwieldy thing to manage.
Yeah, absolutely. So the correlated, the correlated claims will never go up more than the approved balance, right? It's whatever that has been given. And you could only give maximum effective approvals from a validator to any restaking protocols or any modules. If you're already part of a restaking protocol, you withdrawal credential based restaking protocols such as EigenLayer, you're basically giving other modules. Non-withdrawal credential based restaking protocol like restaking called K2 or Node Cloud, you're basically giving that approvals without that one. So there are different types and different forms of how this restaked ETH is being used. Now, this is getting closer to an application logic. This is closer to a hackathon dev to set the rules and say that I want to build something. Hey, validators, can you see this? I registered my module, and can you see it? Can you give the approval? And they can decide 2 or 4, whatever they eat for what they approve balance, they will give you the approval. That's all you got. But you get this kind of many drops makes an ocean. That's the concept of you have 31 million ETH sitting there just to give an approval for every protocol, every innovation that you want, as many times as you. Right. Cool. So
yeah,
that's
what
the
you were saying.
Yeah, 31. Yeah, that's from the beacon chain. So every validator can participate in this. It's a huge liquidity. It's a huge deadline available for nothing stops you to do whatever you want to do. This opens up a market. It's just write a module and then ask, and then it will be given. Okay. Right. So this is we discussed this in the last talk, but we just want to run through once more, give you the hard how the approval works. We discussed about in the previous slides. It's real time, so if you can actually see how many protocols taken approval, how many modules taken approval, MWC will reconcile it for you, so you don't really have to worry about it, right? You have 2 routes. One is approval route, and then there's a lien route, and that we show that one. You want to get into the details on the next slide, or?
Right. Let's see.
Yeah. Let's see. And it is composable too. I mean, yeah. Give it away.
Okay. So within so obviously registration of the balances is required in the MWC. So that's extended from the proposer registry. So proposer registry knows all the validators that are registered, all of them that are active and that have a staked ETH representation, and that can be added to the MWC, and then you build under a single account, your balance that you can issue approvals upon. So and per module, you can there is a max effective approval that you can do. So each of these can get 2 and 2, or more than that. So these are like examples of the different modules that you can issue approval to. Now these modules can actually have can actually enforce a lien upon the ETH and the rewards that the validator is making. So Once that starts happening, there is a reduction in the kind of the on-chain profile of the validator or portfolio of validators, and the ETH coming in from the validator will actually rectify and make the credit rating again good. So this can be USDM is based on is minted from the ETHm. So this is interesting. Like we can get that's going to be an interesting actually topic of conversation. Minting a liquid token from the approvals that has been given here, and what that means, right? So for users that are using the ETHm, so they're using the staked ETH, and they're going to pay the validators for the usage of that. So, but at any time you have a single value against which to reconcile how the performance of the portfolio of validators, and decide whether or not to take on the credit from the validators.
Right. So this is very important that what you're showing here is like, every module can have their own profiles, like the risk profiles. You see that green and amber and red. Depends on what is the type of approvals that you're giving. Is it earning only approvals, or is it something that could actually get you into the debt? Like, for example, if you're giving for Aave, then you say that, oh, okay, I'm going to get 2% or 1% maximum. If you're giving for approvals for K2, and say that, oh, maximum, the upper bound is unlimited, but maximum that I can lose is like whatever that the yield that is going to come in. So there's no yield is maximum. But if you give for DEX liquidity something, you will have slippage. That's not the right. Same amount that you can. If you give an approval for an FC a collateralized stablecoin, you will have additional debt that can be collected. If you take your own overdraft or facility, something that then you have to pay, and that has to go from the yield. So you have to have as many yield modules to be on the other side to pay for your loan payment. Otherwise, it will be gone from your. You have this kind of predictable, quantifiable risk at any given point of time, and you can take that actions based on that one. Correct?
Yeah. The ability to compound this is really interesting.
Yes. So you don't really have to worry about like the ETH price goes up and down, and you just can live. And this goes in line with the raising the max effective balance to 2048, like 2048. Vitalik has a great point that it really allows you to compound, because the solo staker has a huge cost of break-even cost of solo staker is breaking my heart. Like they're not earning enough money to keep the operating costs. They've been left out from every opportunity that we have. Even if you want to go to DVT, the cluster, it just need to have the carry cost of it, an inbound capital is huge. They have to attract, oh my God, 26 validators. That's about 1.4 million for each cluster to be operational to break even. In what way they can get it? They're still going below behind the people who control the money. So it's just we are seeing a societal change that people who are very passionate and very core to or key ingredient of our decentralized future is getting chastised by the kind of incentivized, not misaligned incentivized on the coordination games happen, right? The large pools are taking up and they're giving the farming, but the solo staker has been left out. And this is exactly the reason that we want to give the protocols directly to take that action, who they can take the approvals from, why they want to take it. There could be a lot of activism can come in. The protocols that you're going for approvals, they can curate the validator's profile as well. Like, are you part of a solo staker? Are you part of this? Are you part of that? And we only want to give you that. And that makes a difference. It's not about what you're doing, it's why you're doing it and how you're doing it matters. This is blockchain, this is decentralized world. So we want to give this optionality for innovations to directly incentivize decentralized infrastructure, decentralized capital at stake. Maybe they could also hire them to do something for them. So this is how we build a very modular, very highly resilient world, but capital efficient, incentive aligned. And we are incentivizing in this way, an yield market directly accessible for solo stakers. They were putting them in an equitable fashion, right? They're at the top, they're on the table, always on the table. They're not on the menu, they're always on the table, making that decision. And they have agency to give approvals, and they have accessibility to all those yield markets coming from the restaking, and the protocols can make that decision themselves. They don't have any more other alibis to say that, oh, we don't know how to go there. No problem. We'll provide the tooling. You have this path, your approvals. Now you can even you can self-limit the centralized entrenched parties to come in. This makes account abstraction much more better, because now you can even take more routing, how they maybe should be going, or when you want to give a batches, who you want to do it, even for the blobs and things like that. There's a lot of things that you can take a very the way that we explain is, when you make a decision, the decision can be taken on the fly, but you can actually make a structured decision making process. There's an engagement policy. We will engage if you are having some sort of a in a financial world, you have this kind of term called corporate hygiene, how your balance sheet has been kept. Similarly, how can we keep this decentralization hygiene, the moral compass, that for future? Because there's a lot of money. We are onboarding 1 billion people. We bring a lot of rollups. We need this moral compass. We need this decentralization code. Maybe you can show the underpinnings. Maybe you can show how this is done from the code. I mean, we can talk about it the whole day, but it's also nice to see it in action.
It's Is it a real thing, or is it just or is it something else, right? So right. So the answer is yes, it's a real thing. So why is this not working? Okay. So right. Okay. Cool. So let's do this. So right. So MWC. So firstly, we were talking about the neutral stack, right? So the neutral stack. So it's a contract there, immutable and allows the single sign-on for the validators once you have representation on chain. So that is the thing on top of which the MWC is built on. So with MWC, as we were talking about earlier, you need to bring the balances that are known by the proposer registry for active validators. So one needs to prove that the validator is still active, has an on-chain registration, and is not exiting. That will be continually monitored throughout the life of the registration on proposer registry and any applications on top of that. So we have this concept of proposer registry is like this platform, and then on top of which you build like the MWC application. Then there's the module store, the registry of all the different modules where users can issue approvals, and then all kinds of primitives, all kinds of instruments can be built on top of that, right? So that's kind of the layering up that we have here. But we have a simple neutral base that nobody owns, nobody can influence, nobody can buy a token and kind of take over it's a completely neutral stack. So once the balance has been added in, then this is where you can create the approvals, right? So let's see, can I make this try and make this bigger? I can't make this bigger, but that's fine. So we have the approvals here. So it's simply just a module that can receive an approval of the choosing of the representatives of the validator. So what we do here is that we do a few things. So approvals obviously have some kind of approvals in the ERC20 world. They have known kind of weaknesses. Here we are always tracking the current approval and the previous approval, and that prevents kind of front running issues. So basically, you approve a protocol to ETH, and then you do something that against the protocol, and then or maybe you encounter some kind of slashing that they need to put a lien of 0.1 ETH, and you try and front run the lien by revoking the approval. You can still protocols can still, on the basis of the previous approvals, understand what's going on here, right? So you're either going to increase your approval or try and reduce it to 0, but you will get caught in the middle here. So the modules that have received approvals can create their liens, as we talked about, and importantly, there is this repayment step. So the debt reconciliation can be done, and debts can be cleared off with the repayment, which is either via the sweeps or the exiting of the validator. That can take place here in order to bring the healthy on-chain profile back for the validator or the portfolio of validators there. So this it might seem quite simple, but it's like a really powerful primitive, and this is sort of we keep this core kernel really, really simple, but allow the ability to build really powerful instruments on top of that. But if you can keep this simple, you understand the surface area, you understand what you're dealing with from a module perspective, from a user perspective. You can revoke your approvals anytime. You can repay anything that needs to be repaid in order to keep your access to the other modules and the dApps and the applications for whether it's DeFi version 3 or the credit lines from rollups, where you're earning income from the use of the approvals, the stake ETH that's been extended to the rollups, and you'll get a kickback in terms of interest payments and that sort of thing. Everybody can reconcile everything at all times with the this is like a coordination mechanism to do that. Trying to think if there's anything else we need to really drill into here, but this is that's
a core of the MWC, right? And you can actually do all your business logic in the modules. You can have module kind of SDKs. You want to compose it. That's all outside of the MWC. MWC takes care of the validator, the connection between you, the application logics, and the restaked liquidity at a validator level, every single validator, and then how much you can take it. That's great.
Yeah. All in the modules is correct. That's why we're using like hooks. Hooks is a well understood studied pattern now in smart contract development. So when an approval has been given to a module, the module will get notified about this. The module must implement this interface, and then they will get a notification, and they'll say, this is a risky profile to accept, or this is a one that we do want to accept, and then we can open an account for the account opening. This is all about account opening on those modules. Which is an important first step to be able to use a product. You've got to open an account first.
And this is possible because of the peon stack under the hood.
Yep. Yeah, that's exactly.
Which is there for like it's almost a year now. So it's you do step by step. So what you can do, let's take a use case, right? You want to go back and say that let's give an MWC some superpower. And if you want to use case ETHm, maybe you want to show the slide first and then go to the ETHm.
Okay. That's a good idea. Yeah. Let's talk about this. Yeah.
Right. So this is a use case where modular ETH, where you mint an ETH that could be used for other markets. So we're just going to abstract it, stay in the high level, how ETHm works from the rollups and all the use cases. But what important factor you have here is 3 tiers, right? As I said, 0, 1, 2. You have a monetary base at MWC approvals, and you can pre-mint a faucet of ETHm like WAPT. And this can be brought into the circulation. It could be brought into liquid circulation and lended circulation, right, Vincent? Like you could just issue the loans and then get back, because the faucet has the supply. But every single time the supply is coming into the circulation, it could be quasi-circulation that you're giving, lending directly a loan and then paying back, or you allow someone else to mint the tokens and then use it, freely anywhere. So that's the ETHm in circulation. Or it put it back to the ETH stake, so it just burned the monetary base. So that now you own the equity of the MB. So that's how you get the equity of the MB. Now you own it. So now you borrow, then you own. You're getting better and better. But the ETH stakers gets providing this, and for just for this use case, let's say, at a maximum of a 5% target interest rate, and that is a preferred rate that it will be paid to the stakers in advance before the assets will be reutilized from anything that is coming into circulation. And whatever the assets under the management will be reused for making additional earnings, and then that will goes into the ETH market. So you're really creating a modular ETH to be reused for all kind of esoteric functionalities. Maybe you can take this away from here and make it like super duper interesting.
Right.
I'm trying to hold myself not to get out of, because we can talk about this for a year, for an hour.
Yeah, a year as well. Yeah. Okay. So we're talking about an example module on top of MWC, right? So you have MWC here. You have the proposer registry, and then you have you have the node, right? So node. So this is like we can say this is like consensus layer. Consensus layer down here is like, so below the boundary, so that's the consensus layer. So there is the single sign-on for proposer. Right, the sign-on for the proposer. Then we have we do the registration in MWC, and that gives the approval balances. So now we're talking about this module called ETHm, right? So this is a tokenized representation of the credit lines being extended from the MWC, right? So ETHm is here. So we're still talking L1, right?
Yes. So that's the MB part, right? That's the monetary base.
ETHm is the monetary base.
No, so the MWC is a monetary base, right?
Oh, sorry. Right. Okay.
Approvals, whatever the approvals that's received for the ETHm is the monetary base that you can get. So right, you cannot extend approvals that is not part of MWC, right? So the monetary base is this, yeah. So you have a canonical connection to the ultrasound money at stake.
Okay. Yeah. Super ultrasound. Yeah. So, okay. Can I mint ETHm with like a token?
Yeah.
With like an LST token?
Yeah, ERC20 token, just like in ERC.
But with an adapter, right? So we have like a
so you have a pre-mint faucet for the MWC, and then you get approvals. Now you can mint. This is a minting ceiling is controlled by the MWC approval.
Yeah. Okay. So So approvals come in here, right? So
let's say you receive approval for 20,000 ETH, or let's say 200,000 ETH, or whatever it is, right?
Right. So 200,000 ETH approval from many validators.
MWC. Yeah.
So this is the aggregate approval, right?
Yes.
Okay, cool.
Now you can mint if you want, so that you can pre-mint, like the faucet has 200,000. So if you want to mint an ETHm ERC20 token for liquid, It's just like how you take your cash. I mean, if you want to open it, you put some money, right? We put some money into the ETHm faucet. It could be any ERC20, but it immediately convert into ETH and it will give you an ETHm.
Oh, okay. So, so we can take like a staked. What are we talking about? A staked ETH.
Yeah,
ERC20, right?
Yeah, you can put an EtherFi token, the EE or something like that, and now you get ETHm.
Okay. Right. So
Let's say
so
you put ETH into ETHm faucet, now you have ETHm money, but partially like your MWC approval is also backed by EtherFi deposits, right? And it's staked ETH. So anytime that you're minting, you're paying back to the MWC approvers, which is the ETH stakers. So they get 5%.
Right, this is ETH, yeah? So ETH will mint an ETHm.
Yeah, and so now it's part of the ETH faucet. So it could be used for creating more stake.
Right, okay, yeah. So if we can, so you're doing this because this guy wants to, so ETH holder will earn from ETHm. So ETHm faucet. So wait, okay. So this is the ETHm, right? So then we have ETHm.
And
right?
ETHm has its own market,
token.
right? Yeah, ETHm has its own market, right? Where it can be immediately used for additional yield opportunities, like turbocharged share deposits, flash liquidity, and things. So let's call this an ETHm market. Not explain. So he's actually taking additional yield opportunity risk-taking market, yeah, and then he's getting it. But remember, whenever he mint this, he's also paying himself, as in the validated stake. So you can bring any token ETH or any tokens, right? Per se.
Right. Okay, so that is the yeah. So, but you don't have to mint, right? You can choose not to mint.
So in this case specifically, we are saying that he's minting.
Okay.
The protocols can borrow directly from ETHm faucet, then they're just only using for counting, and then they can pay it back. That's fine. That's a different story. Or you don't have circulating money. You don't have M0. You have only accounts, borrow, credit lines. Yeah. This is like a user. Yeah. User is using it for making additional yield, but he's also getting his the staking protocols collecting lead stakers collecting the money. So now if you borrow from here.
Sorry, I was just going to say ETH through this adapter gets access to additional markets that it didn't have access to before, right? And any other, we can have, so there's all kinds of integrations that can come here.
Yeah.
So rather than ETH integrating into all these markets directly, all the markets just say, I'll take one token, and ETHm is saying we can integrate with other tokens directly. You just mint the ETHm itself, and then you get automatically access to those market if you have those integrations.
Yeah.
Right. So ETH stands to benefit by integrating there, and you minting the you are able to mint ETHm from the faucet. You get the ETHm for additional yield opportunity from these markets, whatever they may be. Okay, so then wait a second. But here we can have as well. We can have because there's the markets. You can have like borrow facility, right?
Right.
So borrow facility.
That's protocol. The modules are borrowing it from there. or you can actually, the other markets can say that, can you give me some ETHm liquidity because ETHm is backed by ETH, staked ETH. I'll pay you interest and you can provide me liquidity, for example, roll-up liquidity or lending loan. But they're not taking it as a liquid token. They're only using for liquidity, right? And pay it back. You're getting an LP token in return. Yeah.
But you're paying for that, right? So you pay interest, for borrow facility.
Yeah.
Okay, so you pay interest for the borrow facility, the ETHm faucet, but then
that's an yield. That's an yield curve. So it doesn't really bring you fresh assets into the asset management, but it just brings you yield to pay back the interest.
Okay, so would I need to stake the ETHm, right? ETHm? Would I need to stake it?
We're not talking about staked ETHm because that's the second market. So we can just at the moment that we are just staying in, how can you even have this, like a liquid tokens can be minted, and that will actually bring new ETH into it, and then it reduce the MWC debt. Because now what you're doing is, like, if you minted ETH and as a liquid token, where you have some inbound money, right, as an asset, and you pay the interest
which goes
outstanding.
To the ETHm owners, right?
Yes, which goes, the ETHm money inbound will pay the outstanding interest for the MWC approvers, and then put the rest of the money into the stake, and then it will become an equity. And that's what the slide shows, is like, and it will burn existing external debt and make it an internal debt, right, owned by equity, because now it has a share of MWC from its own asset. Now it pays its own ETHm, holders. So if you have an ETHm holder, then it will give you more yield because your asset is also staked and is being reused.
Right. Okay. So you okay. So the ETHm holders are paid secondary.
Yeah.
Right. Okay. But they are paid, right? So, pay for use. Okay. Right.
Yield staker.
Yeah.
Just use the yield staker contracts, and then you have this kind of the two preferred and non-preferred. So you first pay outstanding debt, but now what you have is, like, you also make yourself and a preferred debt interest collector, because your equity collect that first, because now it's going into you rather than the external debt, your self debt, right? So this is how this thing actually works. So the ETHm holder actually earn more and more if you're part of it, but providing this liquidity, the stakers actually earns interest. But if you're a liquid restaking token or LST token, if your holder is using this ETHm faucet, you as a staking pool has this kind of additional opportunity, right? So it's just like, how do you compound and make it modular? Because ETHm is being combined. ETHm is just a module, and in MWC, it can draw the credit line for multiple stakers, and it just repay those stakers immediately. And they can also help to re-yield more ETH from the other markets for the same stakers, because you have only 120 million worth of ETH holders. Put it simple.
Yep.
And if you just look at from a macro,
exactly.
you're just basically making this the holders who hold one, one or more, variant of the same ETH. So if you are in the two places, you're collecting the two yield. If you're in the three places, you're collecting the three yield. But you're essentially making the same variant of ETH in multiple ways, and then make that market expand. If the market contracts, and it contracts, but it's just like in a levered basis, right? It's not really like in a cascading basis. It's like more step by step. So now ETHm is very interesting because ETHm as an asset has other things it's built with, just kind of like share deposit liquidity and things like that, because it's using its own protocol suite to find this yield. Now, ETHm could be any other kind of a module asset. They could come, I'm a lending market, I want to get this approval, I want to launch my lending market on 2 or 3 rollups. This is the liquidity, I will offer this. Then you're getting paid for that. So this is just for the ETHm. but it could be like the credit line makes things much more scalable. Just for this, if you earn like about a 5%, what if the other people are paying you? But ETHm is very interesting because ETHm in a modular ETH, that's called ETHm. Modular ETH can give for roll-up liquidities, bridge lending through the gateway, and things like that, which is there. That's why it is borrowing. That's why it is minting that faucet in the first place and say that we'll provide you 5% because the 5% comes from our market. Right? We can yield more from the market. We just need this liquidity. Help us to bootstrap the liquidity. We'll pay you the fees. And we also want the stakers to participate in us, so we can bring more people. The stakers will get, multiple yield raking mechanisms.
Okay.
So you don't really need to have a multi-sig based blast kind of L2s. ETHm can provide that liquidity out of the box. No multi-sig.
Spin it up themselves.
Yeah, double-side liquidity. That's all. We don't want to get into the details of ETHm because that's something like its own beast. But we're just saying that how this is possible. Yeah, cool. All right. So yeah, you can use the MU Plus. It's just like it's truly modular. You have the node CLI tooling. You have the MWC. Modular Withdrawal Credentials comes in. Now you have modules can have different markets. Now we're just abstracting. But all the value accrual is going to the ETH stakers. And that's the thing. And if you are holding one variant or the other variant of the ETH staking tokens, taking a very open approach to get the restake market, come and talk to us. We are here. We can help you. If you're an LRT, if you're an LSTs, if you're staking pool, if you're a solo staker, come and talk to us. We can help you to grow. This is already there in the toolings. We'll be releasing this thing soon, but this is a neutral stack, but we can help you to find more yield. Right. This is how we go. All right. Make restaking modular and free for everyone. Positive games.
Right. Always. Yeah. Exactly. For helping somebody else get the ETH liquidity that they need, you're getting kickback for that. Yes,
absolutely. All right, so this is super cool. So that's for today, and we'll be back soon with ETHm.
Yeah, as always.
All right, guys, happy restaking. Bye-bye.